Okay, our computer clock says 8:30, so why don't we get started? Good morning, Psych Stats. That's a better start than yesterday anyway. We'll get a really enthusiastic response as we go along. Thank you all for finishing up the TED Ed lesson. I really appreciated that. I hope that went well. We'll talk a little bit about that, and we'll talk about your other assignment where you're going to come up with some ratios. But one of the things we didn't do yesterday, and I'd like to do it on the first or second day of class, so I'd like to start out with it right away, is complete a metacognition scale. So on your desks there is a metacognition scale. It looks like it's really long. It's kind of like doing a survey that has about 20 questions. What I'd like you to do first is could you please put your Slater box number, not your name, just your Slater box number up top, if you would, in nice clear letters, so there's no ambiguity about that. My 6s sometimes look like 4s, people tell me. So really clear. And then if you go through and just circle which one of the 5 best describes you. It's almost as if that scale is describing somebody else, but we want it to apply to you. So this is your own self-description, and circle one of the 5 for each of those questions. It does sprawl over 6 pages, but I think you'll get the hang of it. And when you're done, maybe you can place those on the back table. Okay? So take your time. We'll get a good measure of metacognition. when you're done, if you could place those on the back table, I'll pick those up later on. Do another minute or so, and then we'll go on to our next item. Okay, I think we're all set. Very good. So thank you for completing that. I look forward to taking a look at how the class is doing metacognitively. I think it will be very interesting. Before we get into other events for today, I wanted to see if we could follow up on the simple tech check that we did yesterday. Almost all of our technology worked yesterday, and that's really terrific. The one thing that didn't work was SPSS, and the folks in IT acknowledged that there had been a bump that they didn't realize until they heard from me yesterday that we didn't have SPSS. So I wonder if you could please log on. And I guess the first question is whether you have an SPSS icon. I've been teaching this course for many years. Usually the students have an SPSS icon on their desk.
Mine's been doing this since I got here.
Oh, okay. Do you want to move to a different location? Just for now, I'll let IT know about that also. We're fortunate that we have only 9 or 10 students and 20 stations. Usually when I teach research methods, we have a very full house. For some reason, when I taught this course in 2005, that was my first offering 10 years ago, we had 23 people in psych stats, believe it or not. I was told that the course had never enrolled that widely prior to that, and it's never enrolled that widely since. But that particular year, we had more students than computers. But usually in psych stats, we have about 10 or so. Okay, so I'm just going to look around. Do you see something right there? Okay, so we don't have an icon. Okay, can we do the next item, which is to go to this multicolored button, and we'll click on that. Okay, and then we'll put in SPSS. Okay, and I get a hit, at least a hit that I didn't get yesterday. Okay, does anybody get that? So I get that. Here's what I want everybody to verify this with me. Which of these looks promising? The one that says stats, extensions, custom 23, or SPSS. If I wanted to get to the application itself, what should I click on? Okay, let's see how we do. All right, and that opens up to this. That gives me statistics. I get a 23, I get a custom, and I get nothing. I'll go back. It must have been under extensions, and I get nothing. Okay, so I don't have one either, and I wanted to see if anybody else had a different idea about what I should be clicking on. Okay, so I don't have a SPSS icon here. They did tell me that they fixed it and they pushed it, and we did make some progress because I can get an SPSS hit, but not the application. So you all don't have a SPSS icon on your desktop, and when you go SPSS, you do. Maybe Vanessa's found it.
It's called IBM SPSS.
IBM SPSS. Thank you. Thank you. Good eye, Vanessa. All programs, and then it's under IBM. I scrolled through this and I went down to SPSS. I went right past it. Ah, okay. Good. IBM SPSS. Now we're cooking. Okay, now let's go here. All right. Thank you, Vanessa. This is why it's good to have 10 eyes on this thing, 10 pairs of eyes on this thing. And it usually takes a little bit of time to open. We'll see if people get, oh, now this is looking very promising. Okay. And a problem. Let's see. Use Unicode encoding, use local encoding. Let's go with their default. Okay, that's fine. And then we could navigate around if we needed to, but at least we got that far. Thank you. Okay. So let's say this one more day. We won't be using SPSS today, but I think I'd like to use it on Wednesday. Okay. Monday is going to be our journal club. So at least we have that much worked out. Very good. Okay, how many people were able to find that? Did everybody have an okay? And it might be that there's a trick that you know that I don't know about how to turn this in. It'd be handier if we just had an icon here. I'm going to go back, and maybe we can just drag an icon. Oops, that's the license. I want to drag this guy. Cool. Okay, so that might work too. If you want to just drag that over to your desktop, that was simple enough. I think the next time you log in, that icon will be there, and that'll save us a little bit of time each morning when we're using SPSS. Okay. Yes, please.
Mine's telling me that I need permission to drag it to the desktop.
Okay. Maybe they cut me a break because I'm a professor or something. Did you get that too?
No, you can pin it to the taskbar.
Thank you. Okay, that works. Let's see, how many people are able to pin it to the taskbar? Okay. Now we'll find out when we log in on Wednesday if it's still on your taskbar, if we have to do that anew each time, but we're getting there. At least now we have connectivity with SPSS, and that is the one thing that we were missing from the other day. Okay. Enough on that. We don't want to spend too much time on a tech check, but I do want to check in on how things went with TED Ed yesterday. So, yes, please.
So on one of the questions, it didn't have a save my answer button, and I couldn't submit the response.
Okay. So, but that was one of the questions. All right. All right, real good. Okay. Other questions or comments on that? I wasn't really looking at particular answers. I wanted to see if this worked by way of a tech check, so that we could figure out whether the whole class can come in to my area where I can review, just to show you what it looks like from my angle. And this is an experiment. I appreciate you experimenting with me. The idea is to distribute your practice so that instead of hearing information just in the classroom and then it ends, you've got it permanently, and you've got questions to respond to before you come into class. And then we'll do it in class, and then as you're reviewing for a test, we'll have lots of opportunities to see the material many times. So here's this particular lesson, the one that you completed last night. There's the video, and I've clicked into this, and this is the information that it gives me, and so it looks like Wynn might have been the first one to respond, and it actually timestamps all of this stuff. Okay? And I can click on review, and I can go back and I can provide feedback on random questions that she's responded to and so forth. Okay? Go back this way. I can also do this. This is kind of interesting. I can download the student responses, and I think I've got that here. Clicked on that, and I get this. So just so you have some idea about how you and I are communicating with each other, okay? You are responding in TED Ed. All that stuff comes to me, and then I have right over here the date at which that response came through. Here's Shelby coming in at 9:40 yesterday, so maybe you jumped right on it after class. Okay, and you responded on this particular question in your own words, blah, 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 and then here's your response, okay? And I can sort these any number of ways. I can say, give me all the Shelbys, or I can say, give me all the question ones, and that kind of a thing. And so I have some idea about how you've been thinking about the material before you walk in, and that's helpful to me once we get into actual statistical material. This was just a bit of a tech check, okay? So this is what it looks like. Everything is time-stamped, which is also helpful, and it indicates whether this was an open item question or a multiple question, okay? All right? So again, for those of you who are thinking that at some point you might be educators, if you're going to graduate school, there's a really good chance that you're going to be earning a living in graduate school teaching courses in psychology. And it might be the case that you'd like to use TED Ed as a way of communicating with the students that you'll be working with. For 4 years, while I was at Brown earning my PhD in psychology, I earned my living being a TA, teaching assistant, where you are interacting with students, and I wish we had something like TED Ed to work with. So this will get us started for stats, but it might be a nice skill for you to develop. Okay? On that topic, we had two varieties of question. There's the open-ended question, and there's the multiple choice question. And they do different things for us. Generally, at Denison, we prefer to use open-ended questions because they are said to be generative. That Denison education should be about getting you to generate responses and not just click off a D or a C. That doesn't require a whole lot of effort, okay? But actually generating sentences that make sense, that are grammatical, that are on topic and so forth is a good habit to get into. At small colleges like this, when we have desirable student-faculty ratios, 9-to-1, 10-to-1, something like that, we can do that. If you have several hundred people in the lecture hall, you can't do that. The teacher couldn't possibly look at all those generative responses. Okay? So one other way that we're going to generate a response is by asking you to try something new. Can you open up a web browser? Maybe Firefox, if you would. I think that'll work. And I've recently learned about a new kind of website that I think will help us a whole lot. This is called Draw2, and maybe you've already done Draw2. If not, let's go there together. Here's Draw2, and the web address, if you want to put it up there, is simply the word draw.to. And if you hit go or find, I think you'll come to something that looks like this. And this is on the topic of generative responses, because sometimes I'll ask you an open-ended response. In a course like this, and also my SMP course, actually a lot of my courses, I try to get students to generate graphs. It's an interesting idea. A lot of students, when they come to college, actually are not particularly good at reading graphs. By the time you've made it as far as you have, you're pretty good at reading graphs. Developing the skill to draw or generate a graph is actually very different. A lot of people can read something that they can't generate. So what's cool about Draw2 is I might give you a TED Ed question that is open-ended, but it might be something like this. Go to draw2.com and draw me a sample of metacognition scatter plot that shows a diagonal line and has students who are both underperforming metacognitively and overperforming metacognitively, okay? And then you'd go to Draw2, and you'd click down here and grab one of the pens, and you'd make something like a graph here, and a graph here. You draw something akin to a diagonal line. You might put in little dots like this. And please click along with me. You can draw anything that you want, right? And you have different pen sizes. You can also do this. You can click on this guy, okay? And this brings up some kind of a text. Okay, so we'll do this as an example. I'll say that this is my, we'll call this actual exam performance. Okay, and then once I click that there, and once I have that information, I can click into where I want to place that in the graph. And I might want to place that right on my x-axis. Okay, so now I have a nicely typed x-axis label. Okay. I might have a y-axis label that just for the moment I'll call dependent variable, and I might click that in over here. So I'm plotting my DV as a function of my actual exam performance, and I've got something like that. So you don't have to get that just right, but you get the idea that you can do this. If you make an error and you want to undo something, you can simply click on undo, okay, and it takes those away, or you can redo those. Okay. You can clear the thing, you can erase a particular datum or a portion of your line, okay, if you wanted to do that, all right. Here's one other thing I hope you'll join me in doing. If you click on one of the pens, can you sign your graph? So I'm going to sign it NM. Just your initials. It's fine. And it's a little bit clunky. I find it's a little bit hard to move on this thing. It's not quite as fine as a pen, but I think you can see that's probably an NM up there. Okay? Does that work? Some people are getting that to work. Okay? And then here's one other thing we'd like you to do. After you've created your masterpiece, okay, you've answered your question, and you'd like to now somehow get this over to TED Ed, this is how you would do this. If you join me by clicking in the lower right-hand corner of this area where it says Share, okay? When you click on Share, okay, automatically Draw2.com generates a URL for you, as you see right here, okay? And you can grab this thing now, and you can paste it into a new web page if you wanted to, okay? And it's a picture of what you had. So you can send me basically a picture of what you had, not by actually saving a JPEG file or something like that. You just copy and paste your URL to me, okay? And that becomes your answer to question number 7 in the TED Ed lesson. And now I'm not only getting your written responses, but I can also see how you're graphing things. Okay, we're doing that all electronically. It's very, very green in that way. Okay? So we're going to do this in this class. So I think the upcoming, and in fact I know that the next TED Ed lesson that we have, which will be for the Journal Club on Monday, has at least one question where I'll ask you to draw some kind of a graph, and it will be something of a connectivity check. We'll just see if you can get the graph going. As we get a little bit fancier with this, we can see, is the graph accurate? But now we just want to see if you can get the graph going. Okay? Who's okay with all of that? Any questions on draw to? Or our desire to distribute practice across days where we're preceding the actual session where we have that discussion, and we can follow up after the session by going back to the TED Ed lesson. We have these generative responses that are open-ended and they're drawing and so forth. Okay, great way to practice, and for me to see what you're thinking about even before we walk into the point in our semester where I otherwise would have been giving a live lecture. Right? Now we have all this technology that's helping us. Okay, really good. Okay, so we've done draw to. What I'd like to do now is spend just a moment going over the format for the Journal Club. Okay, and I think you have a second handout. You've already done the first handout, which was a handout on metacognition. I'll take a look at those data, and we might even use those data in some of our data analyses. It's one of the fun things about this class is that the students can generate their own data and generate their own analyses. So you don't have to read this in its entirety now, but every Monday we're going to be doing a Journal Club article. And again, as I think I mentioned yesterday, these articles are written typically by PhDs for other PhDs. Okay? And many of you are on your way to becoming PhDs, but you're not quite there yet. So it can be easy to get overwhelmed by many of the details in some of these articles. We don't want you to get overwhelmed. We want you to see if you can stick through it and follow some of these tips. We think that this will be very helpful. I have a separate set of tips that I'll share with you just in the opening minutes of Monday on how to discuss journal articles. Typically what we'll do on Mondays is we'll be at that back table because there's only 9 of us. Okay? I'll say go, usually, and I'll try to remain silent. We'll see how long that lasts. And we'll have you pick up the conversation from there, discussing the article. And of course, you'll be well prepared for that because you will have completed a TED Ed lesson on that. Where I'm going to ask you a bunch of questions, maybe draw some graphs about this, ask you to respond to some ideas in the introduction, method, results, and discussion section. So we've kind of laid it all out. And we'll do that for about a half hour. And then usually, we'll have the last 20 minutes for one of the student presentations. For this particular time, coming from Monday, it's too early, so we're not going to do a student presentation on that. But it gives us a little bit more time to talk about how we run journal clubs. Okay? So that's all available just to make sure people are okay with what's going to happen. That session is going to be our journal club session for 8/31. That's August 31st. If you can join me out on Blackboard, I would appreciate if you could join me out there. And I'm in the course discussion section of Blackboard. Okay? I'm sorry, course documents section. Okay, so if you can go out to our class in Blackboard, and for every one of our sessions, I'll have something here. So we'll say the lecture notes for 827. Okay, you can pop those open. Here are the lecture notes for 828. You can pop those open. So we have those down here. Right, that's what we're going to be talking about today. And then I have lecture notes also for 831. And this is what we're going to have our little TED Ed video on. Here's the set of authors. Okay, one of them is with us. Okay. That's the article that you're going to be reading. And remember that you can find the article by going to your syllabus and clicking on that. Remember that the syllabus was an interactive syllabus, so you can click on that and go right out to the PubMed link just to read the an abstract, but we do want you to read the article in full and answer questions on the article. So sometimes I'm going to have a video, like we did today. We'll have a video, you watch the video and you answer questions. Sometimes I would like the journal article to be a video, but it isn't. It's a journal article. So what I do is I create a little dummy video that says, welcome to accommodation decision making for post-secondary students with learning disabilities. Please make sure that you complete these TED Ed questions. Okay? And then maybe sometimes I'll have a couple of extra slides in that video when we talk about the research cycle or something that might be relatable to the paper. Okay? And ask you to respond to some of those questions. Okay? So that you're actually reading the article that you clicked on through the syllabus. Okay, but you're using TED Ed to respond to those questions. And I can get a feel for where the group is getting stuck or what the group found interesting about the article before I walk into the journal club session. Okay? So it's probably more technology than you've used, but I think it helps us distribute our practice. Let's see if we have any questions. Please don't be shy about asking questions about just what we're going to be doing for Monday. Right, you're going to go out to TED Ed, listen to my little spiel there, and then you can answer those questions after you've done some reading on what you're clicking on. Inside of the syllabus, where you see the full article that Karen and her authors have put together for us. Does that sound okay? Okay, and it looks like TED Ed worked for us fairly well. I got a nice reply from each of you. Okay, so I think that's going to work. I think we're set up for Monday. Okay, any questions or comments on that? Okay, so yesterday we made really good time through all of our stuff. There was one thing that we didn't do, just to show you how far we got yesterday. And that was 8:27, and we made it all the way through all of this. And we were right on track with this. And we made it through this bit where we were assigning folks to different readings and different journal club sessions. By the way, it is good that we have student presentations done before the Thanksgiving break. What I frequently do over the Thanksgiving break is I write letters of recommendation for students who are heading off to graduate school. And frequently, graduate schools want to hear from your upper-level stats professor. Okay, so if I wind up writing a letter for you, if I wind up being your letter writer, I can also talk about the actual presentation that you made. And they like hearing about that because in graduate school you do that kind of a thing. Much of graduate school is reading articles that are peer-reviewed and they're written by PhDs for PhDs. You spend a lot of time doing journal clubs. So it's a really good practice session that we have. And then you'll also be presenting one of these. So I'll be able to speak in detail about your presentations because all of these will be done by the time we get to Thanksgiving break. And that's usually when professors are writing recommendations, at least for seniors, right, who are going to be applying for graduate school next year. Okay, so we got that far, and then we didn't get this far. This was the one slide that we had. So we'll do a little exercise in frequency distributions. Okay, so now I'll ask you if you wouldn't mind, can you walk up a computer? And we'll go back to this glorious picture of the Denison campus. We'll go to computer. Let's go out to the S drive and go to the resources and see if you can go into that file and pick up something that's called a frequency distribution exercise, just like it was called in PowerPoint. Okay, it's an Excel file, frequency distribution exercise. It's under the S drive. I see a sea of these. There's resources, that works. Okay, and then there's an Excel file called frequency distribution. Cool, I think just about everybody is there. Okay, and I'll give you just a little bit of a tip about this, and then I'll ask you to play around with it and think it through. But here's the one tip that I want to give you. When we were doing our exercise yesterday, and we were getting to know you, according to our theme song for yesterday, I was randomly calling on people. Does anybody remember what button I held down in order to generate those numbers randomly? I mentioned it yesterday. It was F9, okay? So when you hit the F9 key one time, okay, and hit the F9 key another time, okay, and there are actually two different tabs here. Let's go to this one. Let's go to the uniform frequency distribution. If you'll join me by clicking on that left tab of the two tabs, it's the one on the left, uniform frequency distribution. You might scroll. Here's your scroll bar. You can go left or right. You can also go up and down. Let's go left and right for a moment. And we'll hit the F9 key once. And then if you're really daring, you can hold the F9 key down. Okay? And here we're creating a frequency distribution just of something very simple. Sometimes cognitive psychologists or developmental psychologists are interested in physical development of children, physical development of adults. And so here we have a very simple variable of height in inches. And we can go all the way up to 80 inches, which turns out to be 6'8", and all the way down to 58 inches, which turns out to be 4'10". That's a pretty good range of adult heights. There are some people taller than that, some people shorter than that, but a lot of the folks are going to fall in this range. And if we hold down the F9 key, we can see that we get a random generation there. My question for you is, I'd like you to play around inside of this. Maybe you can just poke around by going left or right or up and down and see if you can begin to understand how this graph was generated. Like, where are those numbers coming from? How does this thing come to be? Because it might be the case that in a few weeks we have a computer-based quiz, and I'll ask you to create one of these or something like it. Okay? So you're not being quizzed right now, but just see if you can hop around that any way that you like. See if you can figure out how this thing was put together. I'll give you a moment or two to think about that. Frequency distributions is one of the first topics in our chapter readings from our textbook. give you another minute to poke around. And if it helps you to pop on the F9 key occasionally to get a feel for what's causing what inside of this. Okay, we'll see if anybody has any ideas. We're not looking for a complete response here, but what kinds of things might you have observed if you've got an idea about how this comes together? It might also be a complete mystery. Like, we don't know where this graph came from. We don't see how it's connecting in any way to that big patch of numbers over there. Anybody want to start us out and what they found by poking around? Okay, thanks, Gabby.
The numbers down the left side column are randomly generated between the numbers 58 and 80.
Okay, and so the left side column, we're gonna move our cursor over to this side so we can expose column A. Okay? Remember that in Excel we have columns labeled by letter and rows labeled by number, and so you clicked into here, and one more time, can you tell us what was going on there?
The formula says that it's a random number generated between the numbers 58 and 80.
Okay, right, so we can generate integers using that particular command. I wouldn't expect you to know that command, right? There's a ton of Excel commands. We're not going to learn all of them. We might learn a handful here because we're going to find out that they're very helpful for stats. Sometimes we want to simulate populations or simulate samples, and it might help us to be able to randomly generate some numbers. So we're randomly generating some numbers between 58 and 80, and that might look familiar because up here we're generating numbers between 58 inches, which corresponds to 4'10", and we go all the way up to 80, which corresponds to 6'8". I'm almost 5'7" myself, okay, so I can see where I would be in this distribution, okay? All right, so on any one of those, this particular value is 75. If I hit the F9 key, it changes, right? But it's always going to be some integer between those two boundaries, 58 and 80 inclusive. Okay, that was a really good find, okay? Something else, somebody find anything else about how this all comes together? Okay, thanks, Anna.
So the columns have a 1 where the random height matches up with the number across the top.
Beautiful, okay.
For this one, like 68 has a 1 in row L, where it's also 68.
Mm-hmm.
So...
And yours won't look like mine, it's okay, because everybody, as soon as you hit the F9 key, everybody's got a different set of random numbers, right? But to stay with the one that I think you're pointing to, so right here, it turns out that we actually have a 58 corresponding to the 58. So there's always a correspondence between what's going on here and what's going on here, okay? So this number was 60, it should get a hit on the 60 column. This number was 73, it should get a hit on the 73 column. Who's following that? Does that work? Did I lose anybody on that? Okay, is that working? Okay, and there's a little bit of syntax here that gets us that, and I'll mention it now just to get the ball rolling. We won't need to use it right away, but before the semester is out, we'll use these so-called conditional statements several times. In a conditional statement, we have simply an if-then. It's kind of like a decision tree. If the condition is X, we do this thing. If the condition is Y, we do that kind of thing. Okay, so just to take a peek at what Hannah has pointed out for us, it says equals if this particular cell is equal to, and we're pointing to that one over here, is equal to 58 is what all that refers to. If that's true, give us a 1. Otherwise, give us nothing. And I'll point that out one more time. So if this conditional statement is true, if there's an equality between these two cells, okay, then put a 1 there. If there isn't an equality, then put something like that there, and that just shows up as a blank. So we'll have one uniquely matching number. If this guy is equal to this guy, give me a 1. Otherwise, don't give me anything. Okay? That's our conditional statement. Okay? So again, we'll come back to that. We can actually have compound if statements. We can say, if something is true, then answer this if-then question. And if that's true, answer a third if-then. We can develop very complicated decision trees inside of statistical procedures using these simple if-then statements. If this is true, do A. If it's not true, do B. And that's the general statement, and we don't have to get involved for the moment in the craziness of all that syntax. Okay, so those are some really good finds. Anybody else want to say, okay, yeah, thanks. Melissa.
The row highlighted in yellow, the frequency row, for each column it adds up the amount of ones that there.
Excellent. Okay, so Melanie's got something. So Melanie's got this. This is simply the count of how many hits you get. Every time you get a hit, you get a 1 there, right? Okay? Right? So if we get a hit, we're counting up B8 through B1008. We have 1,000 observations in here, okay? Which is why you might have noticed on the title of this, it's called Uniform Distribution of Height in Inches, and n equals 1,000. So when I was creating this thing, I created maybe the first column or so, the first row, and I just copied it down 1,000 times with one big swoop. And Melanie's correctly pointing out that we have B8 through 108. This guy's now going to be C8 through C1008. I said 100, I should have said 1,000. D8 through D1008 and so forth all the way across this, okay? So here, we're generating a number. We're seeing, did we get a hit? Where did we get the hit? And then we sum up those hits. And then over here, as you might have guessed, if you'll join me just by clicking, I think, almost anywhere inside of this, inside of the graph. Okay? Once you click on that, Excel comes back and tells you this graph comes from that highlighted area. Right? So I'll click outside of the graph. And notice when I click inside of the graph, all those red, yellowish things become highlighted. So it's saying that this graph is being driven by these numbers. As Melanie pointed out, these numbers are coming from the sums of the columns. The columns are either hits or no hit, and that's all based on this random number generation from over here. Okay, so we generate some numbers, we tally those numbers, and we create a uniform distribution. That's the basic idea. Who's following that general logic? Okay. All right, so this is one way of modeling. We call this a uniform distribution because any one of the observed values here is equally likely. This is the nature of the very first command that Gabby pointed out. If we go back over to column A and we use rand between, all of the values in that range are equally likely to occur. It's said to be a uniform distribution. No one is more likely than another. In a particular instant, you might get more 58s than 59s, but if you hit the F9 key again, it reverses. Okay? The same thing is true for the other command. It's near neighbor. There's one called rand, left paren, right paren. That gives you a random number between 0 and 1. Okay, so when I was generating the random numbers yesterday, and you saw that somebody was the winner, the person who happened to have instantaneously the highest number, that came from a uniform distribution that was between 0 and 1. But you can specify that to any level that you like using rand between. Okay? Can we do the same kind of a thing, but now I'll ask you to click with me, not here, but can we click on the second tab? The second tab says normal frequency distribution. Okay? And you might, if you were to toggle back and forth between those two, you might see that they have different shapes. And yet they're still plotting the same concept. The concept that's being plotted is height in inches. Okay? I might need to show that just a little bit further. Okay? And hit the F9 key here, you're getting what we might call a bell-shaped curve. We might call this a normal curve. And in honor of Friedrich Gauss, who was the person who developed this curve for us, we might call it a Gaussian curve. Can we all say Gaussian together? Say it with me. Gaussian. All right. We're going to be talking a lot about Gaussian distributions. Okay, so if you hit the F9 key, you get those. So I'll give you just a moment to hop into this particular spreadsheet, move around. You'll see a lot of similarities, but it differs in some important way from the other spreadsheet that we just looked at. Okay? So what can we find about this particular, the details of this thing, that would account for the difference, why this thing is Gaussian distributed here versus uniformly distributed here? What syntax is driving that? I'll give you a moment to poke around and see if you can find that. Even if you don't understand the syntax, you can say, well, this one looks different on this page versus the other page. Okay, how many people think they found the culprit? What's driving that? Okay, okay, I see two hands. We'll give another moment or so. Just poke around. The structures are largely the same in these two. But something's driving this thing toward a bell-shaped curve, which we call normal, or we call Gaussian. Okay, if you think you found the smoking gun, can you raise your hand? Or at least you have, okay, I think several people have that. Okay. Victoria, do you want to help us with what you think it might be?
What I think it is the left-hand column again.
Okay, let's go back.
Height in inches
Okay.
Instead of doing
there's random numbers.
Okay.
Things.
It's something crazy.
Yeah.
Okay. But that one's different, and that's the one that's driving this difference, okay? So I did some simple rounding here. So XL can round up, XL can round down, and this is a function. A function is a rule for turning one number into another number. That's going to be one of our mantras. A function is a rule for turning one number into another number. I'm going to use the round down function, to take some number and turn it into another number that's just rounded down or rounded up. In this case, I'm rounding down. Then I have this normal inverse function that I won't ask you to think about for the moment, but we'll be thinking about this for Wednesday after we make it through the journal club. Okay? And we're going to get some kind of a normal or Gaussian curve that takes a mean and a standard deviation, and we might get some kind of random variable from a distribution that is normally shaped, right, or bell-shaped. Right? We're going to get some kind of value randomly chosen, and we might say that it has, a mean of, let's do it this way. This is kind of fun. Let's go over to here. I have a mean of 70 inches, and I have a standard deviation of 2 inches. Okay? I've clicked all the way over to the area of column Z and column AA. If you need to slide over a bit, you can see that this one is just a little bit more complicated because this particular function takes in some instructions. It takes in a mean instruction. It takes in a standard deviation instruction. Just yesterday we talked about having central tendency and dispersion. So the distributions that we're going to be talking about in Chapter 1, and that you might have done some reading about already, and to some extent in Chapters 2 and 3, we can talk about their means and their standard deviations. So just to give you an idea about this, I'm going to ask you to put your cursor right there on AA. That's AA1, and you've got the 70. And before we do anything with that, can we just hit the F9 key? And we can convince ourselves that these graphs are generally centered around 70. Okay? That we're getting the biggest spike in the number of observed heights at around 70, which is where we set our mean. Okay? And you can go crazy, just hold it down and let this thing go. Remember, every time you hit those, you're generating 1,000 new random numbers. You can have a more elaborate model that does 10,000 numbers. We're just doing 1,000 at a time. And we're getting a nice descriptive summary as we're doing some descriptive statistics here. Okay? All right. And then, why don't we do this? Why don't we leave 70 just where it is? Why don't we change the standard deviation? Let's go to 4. I'm going to make the standard deviation 4. And when we do that now, we get a wider distribution. Okay? So instead of having the standard deviation be 70, or the mean be 70 plus or minus 2 units, right now it's plus or minus 4 units. I can make it a fancier number than that. I think I can go with fractional numbers. We'll see if that, okay? I can make it just a little less distributed. I can back it off by going 3, 2, 1 is going to be very, very spiky. Okay, right? It's a really, really narrow range. All the while, you can see the full range going from something like, what did we say, 4'10" to 6'8", whatever those numbers were. 6'8", 4'10", okay? So we're always operating over the same range, but we have either a really broad range or a really narrow range. Who's following that? Is that working for us? Okay. So just by changing this variable, okay, we're changing really the nature of this particular Gaussian, but it's always a Gaussian distribution because we're always a normal distribution or a bell shape because every one of the random numbers still comes from what Victoria correctly identified as being something that wasn't uniformly distributed unlike the other page. Right? It's now Gaussian distributed or normally distributed, and it takes in a mean and a standard deviation that you can set. Okay? Just for kicks, why don't we play around with the other parameter in this model? This is a Gaussian model. One of the parameters is the standard deviation. We can make it fatter or thinner. We can shift this thing left or right by changing the height up or down. I'm about 5'7", so we'll see what it would look like if we were centered on me. And if we had a standard deviation of 2, right, you can change that back up to 75 inches or whatever you like, and you can make this thing move around from left to right. And this is very clearly then a different kind of a distribution. This is a unimodal distribution, as we'll be talking about. It has one mode. It also tends to be fairly symmetric. It's about as heavy on this side as it is on that side. And if you did this many, many times, it would be perfectly symmetric. Okay? Okay. All right. How many people have had some success with that? You're able to change the mean and the standard deviation, move the thing left and right, make it fatter or narrower. Okay? What's interesting about this is most of the graphs that you've ever drawn, probably in your life, have the dependent variable on the y-axis or the ordinate, and they have an independent variable or some kind of predictor variable on the x-axis or the abscissa. Here, we always fix the y-axis or the ordinate as being frequency count. And it might be the actual number of observations. It might be some kind of normalized number, like a percentage. Okay? So it might be that this goes from 0 to 100%, or it might be the number of observations that you have, something like that. And the variable of interest is plotted down here. The other day, when we were talking about the mean and the standard deviation for central tendency and dispersion, I said we plot something up this way, and I made this gesture. I went like this with my hand, and we said that we had error bars that told us about the standard deviation. If you can think about it, this is a relatively wide standard deviation. That's narrower. Wider standard deviation, narrower. If we now just turn that graph on its side, we get wider or narrower standard deviations. Okay, so we want to be able to think about wider or narrower standard deviations, whether they're plotted on the x-axis, as they are here. Put it back to the center. Okay. That's relatively, we'll call that narrow, we'll call this one wide. Okay. It's kind of like going like this or like that had this been a regular plot as opposed to what we might call a frequency distribution. Okay. Okay, questions or comments about any of that? I won't ask you to construct all that now, but I've got some intuitions about where these numbers come from, how different cells inside of Excel can talk to each other, and how they can collaborate to generate different kinds of graphs. We use a simple example of height in inches and two different forms of these distributions. We saw a conditional statement and so forth. So just a little introduction to some of the tricks that you might be able to put together to solve some kind of problem using Excel. No questions or comments on any of that? Okay. I invite you to use the F9 key to your heart's desire so that you can get a feel for how these things come about. What I did want to do is spend just the last moment or two on our simple exercise. This was an easy one. I asked people if they wouldn't mind thinking about a couple of different ratios, because we're going to be having ratios, something in the numerator, something in the denominator. Anybody want to offer a ratio or two that they thought was interesting? Maybe novel or creative? Any ratios? Okay, thanks, Gabby. Really? I didn't know. Okay, so that's the bedroom square footage to the total square footage. Okay. Is the idea that... Oh, they want bigger bedrooms. Okay. For 4 years, when I was at Columbia University, I lived in a studio apartment that was, the square footage was about the size of this row, and that row. That was my entire living space, right, for 4 years, okay, right? And most of that was bedroom, so to speak, right? So I would think that like a mansion would have some nice bedrooms, but it has many, many other rooms. So really luxurious living spaces might actually have a low bedroom to, right, okay? But if they're looking for a lot of bedroom space, that's what that ratio is helpful for. Something else, a couple of other ratios? Yeah, thanks, Gwen.
Like for decorating dorm rooms, a lot of us like print out pictures, and sometimes you have to like crop the picture, and you can like choose the different ratios of like the size of the pictures.
Okay. Okay. The aspect ratio. Okay. That actually, that's a very well-known phrase in photography. The length to the height. Okay. Something else? Thought I saw another hand or two. Why don't we take two more? Okay. Why don't we go with jump?
Currency exchange.
Currency exchange. Okay. Can you unpack that for us? The numerator and denominator might be.
How much like euros to an hour, like that.
Okay. Okay. We'll end with Melanie.
Medication dosages.
Okay.
Like milligram of whatever medication per kilogram.
Okay, milligrams per kilogram, right? Okay, so they're kind of everywhere. So we get the idea about ratios. Okay, so we're out of time. Why don't we do it this way? We'll just wrap up here, and we'll ask you to look at the TED Ed lesson and see if you can respond to all of those, and we'll set up the journal club. Remember that you actually find the article itself by going to the syllabus, and from the syllabus you would then click on that, go out to the article, read that, answer the questions, and then we'll be back here. You have a little tip sheet there for how to make the most of your reading time. Okay? Thanks for a great couple of days. I look forward to seeing you Monday at 8:30. anybody else get that licensing issue inside of SPSS? Did you get prompted with some kind of a license question?
Yeah.
Do you remember what it said?
Just accident. Oh no, I don't. I can look.
Could you generate it again? And I wonder if you can do a screen capture and maybe send it to me.
Yeah.
Do you know how to do it? Okay. That's this kind of a thing. Print screen. Okay. Thanks. Thanks very much, Vanessa. See you all. Karen, thanks for the heads up about share.
Yeah, I was like trying to tell my professors getting a class for that. This is all I can.